How are you?
Good, thank you.
How was your assignment? Could you finish your homework or too busy with your schoolwork?
I finished the chapter 5 homework, also chapter 4 I will send it to you. And the test, I'm finishing it. I will send you like maybe tomorrow.
Tomorrow, okay. Okay, Selen, did you try to use that cam scanner?
Yes, I did.
Okay, so you know how to use it, right? Because still, I explained a few times, but students, some other people that did not understand. It's like a scanner, you know, because if you just take a picture of each page one by one and send it to me like this is not a practical way. I mean, it will be hard for me to categorize and your work and also having a look. So using camera scanner, you have to scan all the pages and combine them in a single PDF file. Already actually they have it has those functions. And when you are sharing with me, you need to share as a PDF file. And before you share this file, also you have to rename it. For example, let's say you're going to submit your test 1, right? Okay, the test 1, right, test 1. And after that, add your name to the file name so that I can say that, this is test 1, Salim, test 1, Ibrahim. Okay, do not send separate pages. Okay, just you need to combine in a single PDF file and share with me. But I need to name each file. You said so. Yeah, you need to. What do you mean, Selin? I need to name each file. You
I
said
mean,
so. What do you
like,
mean?
for example, I'm writing there chapter 5, exercise like 5A and then 5P and something like this, maybe.
Okay. So, Selin, for
But if I
example,
will
you
do,
open this file. For example, let's say A5. Okay. Exercise. Let's say exercise 5A, B, C. For example, that's the one file. Okay. So you download this, right? And you do the questions on the A4 size. That is your first page. Let's say this is your second page, and that's your third page, and that's your fourth page. Okay. After actually just scan these pages, and you will just see this in camera scanner, right? And after that, you have to rename this. Now again, use this file name A5 exercise 5 ABC, and next to it, add your name, Selin. And after that, you can send this to me.
okay.
All right. Okay, Selin, do you have any question from chapter 5? Because today we are going to talk about chapter 6. That's about number sequence. If you have any question about chapter 1, 2, 3, 4, 5, 6, we can have some discussion for 5 and 10 minutes. After that, we'll start our class.
I don't have any
can you solve
question.
all the questions in chapter 5?
Just the exercise review questions 5, and 8 and 9 were like a bit of hard to me.
Which one is it? Can you tell me the exercise name and the question number?
Review questions in 8, 9.
Question 8 and 9.
Mm.
Okay. This question? Selin?
The homework.
Yeah, this is your homework, right? Review questions 5, question 8 and 9.
But this was like a tense question.
Say again, what is it? Is this is it this question you're talking about, Selen? It is from review questions 5, question 8, and this is question 9. The average salary of M male employees and F female employees of a company. Is it this?
I'm sorry, my battery, like, I need to charge my iPad, but I'm joining from phone, and that's why.
Are you talking about these questions, Selen? This is question 9, and this is question 8.
The one you, okay, now I'm gonna open on my phone, just to tell you.
Say again, I didn't hear well.
I will tell you now, just 1 second, I'm gonna open the file.
Okay, okay. Ibrahim, welcome.
Hello, Mr. Abdul Chazam.
How are you? Did you finish your work, homework?
Yeah.
Could you solve all the questions?
Yes. I have
Oh,
one question I didn't do.
which one?
Wait, I'm looking. 8C.
Question 8C. Is it this question from review questions?
Yeah.
Okay. Selen, what happened?
I mixed up the question.
Okay. Okay, have a look. All right, we'll get back to these questions then. Let's have some class. Maybe again, the last 10 minutes we may
But
have.
do we do the review questions and the exercises like in the class?
No. The exercises
The
we don't
same
do
as
in the
homework?
class time. Only review questions we do together in the class.
Oh, then I don't need to do the review questions?
No. You should do those questions once again. As you see here, some questions, because listening to somebody and doing yourself, it is different. Sometimes, when you just listen to me, you may actually think that you understand everything, but when you just do yourself, you will see that you might not understand everything. Okay, that's why, to make sure that everything is clear, you should do those questions again. And the review questions, I didn't do all questions. I just selected some questions, as you see here. For example, from 7, I chose only 7C and D. And from 6, E, H, and I, for example. And 5, only I and J, for example. 4 also. Okay, so you have to do all the questions one more time. Even if you did it in the class, intentionally, I do some questions here together, but still you have to do those questions once again yourself. Okay?
Okay.
Okay, guys, let's continue. Then just keep your questions. Maybe the last 10 minutes we will discuss together. And today we will talk about number sequences. Okay, and that's also very easy topic. And we will just go through very fast. I think if we have any question, we may stop and have some discussion. And again, here in these courses, we are just talking about some basic concepts. Okay, that doesn't mean that we will not learn them again. Next time also we will learn it in a more depth. Okay, so chapter 6 is about number sequences, and after this chapter again we will get back to algebra, because chapter 7 is about solving equations. All right, what are we going to learn in this chapter? We are going to learn how to recognize simple patterns from various number sequences. Of course, before we start this, first we have to answer the question, what do we mean by number sequences? Okay, First, we will just give its definition, and after that, by practicing a few problems, we will improve our recognizing skill. When we just look at the number pattern, we should be able to recognize the pattern, how numbers are changing, how they are related to each other, how to continue a given number sequence and find its general term. That's really important concept here, this general term, and you're going to use maybe even in the, what is it, subsequent grades at college level, at university level. This general term is very important concept in math, and also about problem solving heuristics. Anyway, let's just start with this introduction, okay? And after that, we'll talk about number sequence. Suppose a pair of newborn rabbits takes a 1 month to mature and starts to reproduce a pair of offspring 2 months after they are born. Okay, so that means to reproduce means they give a birth to new babies, right? They reproduce a pair of each month after that. If we started with a pair of newborn rabbits on January 1st, 2010, how many pairs of rabbits will there be on the 1st of January 2020? Okay, so that is a problem that people discussed in the past many years ago. Actually, that is very simple example how we should learn to deal with number patterns or number sequences. Okay, now let's see in the picture. Here in the question, it says that if we started with a pair of newborn rabbits on January 1st, 2010, right? So here we have 2 rabbits. Actually, now today is actually a newborn. What is it? It is 1st of January, 2010. And in the question, it says that suppose a pair of newborn rabbits takes 1 month to mature. In 1 month, they become adults, and after that starts to reproduce a pair of offspring 2 months after they are born. So during this month, okay, the first month, they become actually mature. And after that, after 1 more month, right, they start giving a birth to babies. So these are parents, maybe mother and father, or father and mother. So now they have new babies after 2 months. So now these adults, after that, each month they give birth, right? And for these new babies, again, it takes 1 month to mature. And after that, again, they give babies, they reproduce new babies. So now if you just write here, 1 by 1, month by month, here we have January. Let's say here we have February. Let me just write the first letters. Okay. Okay, this is our first month, January, and February, and March, and here we have April, and May, June, July, August, September, October, November, December, and again January. So in January, how many rabbits would we have? Here we had 2, right? And the second month, still we have 2 because now they become mature. Still here we have 2. And after that, here we have 2, right? And here we have how many? Here we have 4. So here we have 4. And after that, how many rabbits we have? Here we have, what is it? Okay. Let me just count in pairs. All right, 6. And here we have 4. And here we have 4. And here we have 6, right? And after that, here we have 2, 4, 6, 8, 10. Here we have 10 and continue. Now these are pairs. If I just write them in pairs, here we have 1 pair in January. We had 1 pair of rabbits. Again, in February, we had 1 pair of rabbits. And because they give birth to 2 new babies, now here we have 2 pairs of rabbits, right? 1, 2 pairs. And after that, in April, we have 3 pairs. And in March, we have 5 pairs and continue. Now, if you just continue these pictures, we can draw more. As you see here, we have a kind of pattern here. Here we have 1 pair and 1 pair, right? Adding these 2 together, here we have 2 pairs. And the previous 2 numbers, 1 plus 2, it is 3. So 2 plus 3, it is 5. There's a pattern here. to get the next term here, we need to add the previous two terms, right? So here 2 plus 3, it is 5. 3 plus 5, it is 8. 5 plus 8, it is 13. 8 plus 13, it is 21. 13 plus 21, it is 34. 21 plus 34, it is 55, dot, dot, dot. Okay. After the end of first month, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, and maybe 11th month, here we have 89. And 12th month, it is 89 plus 54, that is 144. So on the 1st of January, that means that we will have 144 pairs of rabbits if the number increases in this way. Now we will get back to this number sequence. This is one example in real life, how actually we use number sequence. Of course, in a lot of times we have patterns in real life, right? And another example, okay, that's just one example. Some other examples for number sequence. Okay, let's talk about this number in the next slide. So what is a number sequence? Number sequence is a list of numbers that are linked by a rule. Well, what is rule? Now we'll try to find how to find this rule. If you work out the rule, then you can work out the next numbers in the sequence. Let's just see first, very simple example for number sequences. Natural numbers, for example, 1 and 2 and 3 and 4, and immediately you'll see the rule, right? Here, these numbers are increasing by 1, right? To get the next term, we should add 1 to the previous term. Right here, 4 plus 1, it is 5. 5 plus 1, it is 6, and dot, dot, dot. Another example, how about these numbers? 2 and the 4, and here we have 6, here we have 8. Now you see the pattern already, right? Here we are counting in 2's here, right? To get the next term, so we should add actually 2 to the previous term. So that means I start with 2 and add 2 to get the next term. So 2 plus 2, it is 4. 4 plus 2, it is 6. 6 plus 2, it is 8. 8 plus 2, it is 10. 10 plus 2, it is 12. And how about this one? 1 over 2, 2 over 3, 3 over 4, and continue. What is it here? We are writing here fractions, but each time, right, the numerator of the fraction is 1 less than its denominator. 1 over 2, 2 over 3, 3 over 4. So the next one will be 4 over 5. Next one will be 5 over 6. And dot, dot, dot. These are just some examples. As you see here, each case, the first one, what is it? It is a list of numbers, right? And they are linked by some kind of rule. What rule is it here? Actually, the difference between any two adjacent numbers here, right? It is equal to 1. Or to write this number sequence, what is the rule here? Start with 1 and add 1 to get the next term. And in the second one, start with 2, add 2 to get the next term. And how about here is a fraction. Each time fraction actually numerator start with 1 and denominator is 1 more than the numerator. And always just getting, how to say, moving in this pattern, right? 1 over 2, 2 over 3, 3 over 4, 4 over 5. Anyway, we are going to talk about this kind of problems. For each sequence, state a rule and write the next 3 terms. Okay. We can see. Selin, let's start do with you question A, Alakbar B, Ibrahim C, and maybe D together. Selin, what is a rule? Excuse me. Selin, what is a rule here? 3, 8, 13, 18. So what is the pattern here?
Plus 5.
So start with 3, right? And add 5 to get the next term.
Yes.
Because also this starting point is important, right? Okay, plus 5, okay, plus 5. Adding 5 to what number? So you should say that start with 3 and add 5 to get the next term. So, okay, now we know the rule. So here, if you have 3 plus 5, 8, 8 plus 5, 13, 13 plus 5, 18, 18 plus 5, 23. It says next 3 terms. So 23 plus 5, 28, 28 plus 5, it is 33. Alakbar, how about question B? What is the rule?
Okay. -6, -6. And
First, you should say that how you are starting your number pattern. You should say start with 38.
yeah,
Start with
and
38
minus
and subtract, right? Subtract 6 to get the next term. So this 38 minus, here we have 38, minus 6, 32, minus 6, 26, minus 6 is 20, 20 minus 6, it is 14. What is 14 minus 6? It is 8. 8 minus 6,
8.
it is 2.
2.
Ibrahim, how about question C? What is the rule? First, can you state a rule? And after that, we will write the next two terms of this number sequence.
2 multiply 3. It's
No,
6
first, when you're
and
writing the rule,
okay.
Ibrahim, always say, okay,
Yeah.
you are starting with what number, right?
Yeah.
The starting point is important. So start with 2.
2 and 6
And
and 18.
start with 2 and multiply by what? 3
3.
to get the next term.
The next
Each one is term,
is
right? I'm starting with 2, multiply by 3, I get 6. Multiply by 3, it is 18, right? Multiply by 3, it is 54. What is 54 times 3?
it's 1062.
162.
100, sorry.
And multiply this by 2, 3 times 2, 6, 3 times 160, 480, 486. And multiply by 3, 3 times 6, 18. We have 1, 3 times 8, 24, 25. We have 2, 3 times 2, 4, 12. So here we have 4. That is 1,458. Stalin, how about the next question? D, what is the rule? First, can you state a rule?
Here multiply, no, divide by
Start with 128.
128. I will subtract from
And
128. I will subtract 64 firstly.
divide, right? We are dividing by 2.
Yes.
Divide by 2. Divide by 2. Okay. So what is the rule here? Start with 128 and each time divide
Divide by 2.
term 2 to get the next term. Okay. 128 is divided by 2. That is 64. 64 is divided by 2. 32. So 16 is divided by 2. It is 8. 8 is divided by 2. It is 4. 4 is divided by 2. It is 2. So the next three terms of this number sequence are 8,
4 and 2.
4, and 2. Okay? All right. Now, Fibonacci sequences. We have already talked about this at the introduction part. So this Fibonacci, maybe also you can, when you have time, you can do some research on Google and YouTube. There are a lot of beautiful videos about this Fibonacci sequences. And it appears in a lot of situations in real life, like in nature, in human body, and golden ratio, blah, blah, blah. I just here talk about how actually we construct Fibonacci sequences, okay? And just to get some idea, later maybe we will talk about this in more detail. So Fibonacci sequence, this Fibonacci is a mathematician from Italy. I think he lived in 16th century something, all right? So the number sequence, which is like starting with 1, and the next term also is 1. Now to get the next term, just add 2 preceding terms. So these are preceding terms, right? 1 plus 1, it is 2. 1 plus 2, it is 3. 2 plus 3, it is 5. 3 plus 5, it is 8. 5 plus 8, it is 13. 13 plus 8, 21. 21 plus 13, What is it? It is 34, 55, 89. We will continue. Okay, and this sequence is called Fibonacci sequence. And what is the rule here? Start with 1 and the 1, right? Because these numbers are starting values. Okay, and add two preceding terms to get the next term. So 1 plus 1, 2. 1 plus 2, 3. 2 plus 3, it is 5. 3 plus 5, it is 8. 5 plus 8, it is 13. So now that much is enough. So that's called Fibonacci numbers. I mean, it's just the basic idea for now. That's enough. How about Pascal's triangle? Pascal's triangle also appears in expansion of binomial. What is this? Binomials, like for example, let me just write here some stuff here. A plus B to the power of 0, for example, we just actually that's equal to 1. How about A plus B to the power of 1 is equal to A plus B? And how about A plus B squared? If you expand this stuff we will learn a bit later. Just watch and how to write this. That much is enough for you now. That's equal to A squared plus 2AB plus B squared. One more, A plus B cubed. That's equal to A cubed plus 3AB squared plus 3AB squared plus B cubed. Okay. Now, if you notice here, this Pascal's triangle starting with 1, let me just write here 1, and here we have 1 and the 1. Now, if I just start here with 1, 1 plus 1, it is 2, and here we have 1. Now, again, start with 1, 1 plus 2, it is 3, 2 plus 1, it is 3, and here we have 1. Again, start with 1, 1 plus 3, it is 4, 3 plus 3, it is 6. 3 plus 1, it is 4. And here we have 1. And once again, here we have 1. 1 plus 4, it is 5. 4 plus 6, it is 10. 6 plus 4, it is 10. 4 plus 1, it is 5. And here we have 1. We just continue. Now, also here, there's a pattern here, right? Here I start with 1. And after that, here we have, okay, here's just 1. So that's why I'm writing here 1. And nothing here. Here also we have 1. Now, because here we have only one term, I'm writing here 1, 1 plus 1. In the previous line, it is 2, and here we have only 1. Now, 1 here again, 1 plus 2, it is 3, right? 1 plus 2, it is 3, 2 plus 1, it is 1, and here it is 1. Okay, as you see here, it forms a triangle, and this Pascal is a mathematician, and he discovered this pattern. That's why it is credited to his name. Now it appears in a lot of different places, but here, as you see here in the expansion of this binomial, a plus b to the power of 0, that is 1. So here we have the first line. And how about the second one? Here we have 1 times a, 1 times b. These are the coefficients in the second line. That is 1 and 1. In the third line, here we have 1 times a squared, 2 times ab, 1 times b squared. These are the coefficients of this. And how about the next line, a plus b cubed? Here we have 1, 3, 3, 1. So here we have 1, 3, 3, 1. So now, if I want to expand, for example, here we have fifth line, right? A plus b to the power of 5, for example. What is it? I should just write here, we have a, and here a to the power of 5, a to the power of 4, b, a 3, b squared, a squared, b cubed, and continue. The coefficients will be, the first one will be 1 here, the second one will be 5 here, plus 5, and third one will be here 10, and next one will be also 10. Okay, using this pattern, we can just write the coefficients of this binomial. And also there's a pattern here. It is related to number sequence. That's why it is given here. And later, when we solve problems, we will talk about this stuff. I'm just giving here to give you some information about what kind of number patterns we have. Also, we may have different number patterns. Okay, what time is it? 32. Now let's talk about general term. After that, you'll have some break. Okay. Alakbar, how are you?
I am fine.
Alakbar, your telephone is Android.
Yeah.
So did you actually download this app, Cam Scanner?
Okay.
Did you download it or not?
No.
So Alakbar, you have to download this in Play Store. You just write Cam Scanner. It will come at the top. It's like CS, okay, in the like blue.
Okay.
So you have to install, and you have to scan your work with this app and save it as a single PDF file, then send it to me, okay? Do not send me like separate page.
Okay.
Good. Now, a general term of a number sequence is a formula that is used to calculate any term of the sequence. That is also, as I told you, a very important thing. You're going to use this concept a lot. Again, let's just talk about the first number sequence. Here we have 1, 2, 3, 4, dot, 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 right? And that is a first term, second term, third term, fourth. And how about the nth term? As you see here, it is 1, 2, 3, 4, 5. So the nth term will be n. After that, it will be n plus 1 and dot, dot. So now I can just write n general term as a sub n. That means that the general term, that is n. What does it mean? That means that if you want to get the first term of this number sequence, I have to substitute 1 for n. So that is a1, that is 1. That means that the first term of this number sequence is 1. And how about the fourth term? Let's say a sub 4. That means that here it is 4. As you see here, that is the fourth term of this number sequence. So the general term is a sub n is equal to n. This is how we write the general term. And how about this number sequence? 1, 3, 5, 7, dot, dot, dot. As you see here, the first term, I can write it as 1. And second term, I can write it as 1 plus 2. And third term, I can write it as 1 plus 2 times 2. Maybe, okay, it doesn't matter. So these are odd numbers, right? This is the first term, second term, third term, fourth term. Then what will be the nth term here? So the nth term will be here, as you see here, these are odd numbers, right? 1, 1 plus 2, 1 plus 2 times 2, 1 plus 3 times 2. So here, the nth term, let me just write b here. The nth term will be 2 times n minus 1. What is n here? N is natural number like 1, 2, 3, 4. Okay, so that is the general term of this number sequence. As you see here, for example, b sub 1. What is it? It means that it is the first term of this number sequence. That is 2 times 1 minus 1. It is equal to 1. The first term of this number sequence is 1. And how about the fourth term? Let's say b4. That's equal to 2 times, I should substitute 4 for n here. 2 times 4 minus 1, that's equal to 7. Actually, this fourth term of this number sequence is 7. And how about 100th term here? So that's equal to 2 times 100 minus 1, which is equal to 199. If you just keep moving at this pattern, right? In this pattern, that means that the 100th term of this number sequence, you will have 199. And this is how we find the general term of a number sequence. Again, why we should find this? Actually, to be able to write any term of the number sequence without writing all the terms. As you see here, if I just see the pattern, I know the pattern here. So that now using this pattern, I get the general term formula, right? And using this formula, I can tell you any term of this sequence. If you just tell me what will be the 1000 step here, for example, substitute here 1000, 2 times 1000 minus 1, so it will be 1999. All right, guys, let's have some rests. I think you're also a bit tired. Not 5 minutes, 4 minute break, okay? After 4 minutes, we will continue. All right, guys, let's continue. If you are there, we have 15 minutes left. Okay, general term in a number sequence. These are really easy examples. Maybe after we finish a few topics, after that, maybe once again, we will get back to this topic in a depth, all right? In general, if you're given any number sequence, how do you find a general term? For now, you're not ready. At least I have the feeling that we need to practice a bit different questions before we talk in depth about this topic. Anyway, so general term in a number sequence. The diagram shows the first four of a sequence of figures. Figure 1 and figure 2 contain 6 dots and 10 dots respectively. The sequence continues as shown in figure 3, 4, and so on. Let n denote the figure number and d the corresponding number of dots. Okay, so here we are just using n. What is it? Then figure number. That means that this is the first figure, that is a second figure, and that is a third figure, and fourth figure, dot, dot, dot. This will be n's figure. And here it says, and d, the corresponding number of dots. So in nth figure, how many dots we will have? We will have n dots, okay? So count the number of dots in each of the figures 3 and 4 and write down the next two terms of the number sequence, 6, 10. So here we have the first one, 6. Next one, here we have 10. How about the number 3? How many we have? Here we have 5. Here we have 5 plus 4. So that is it 14? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's 14, right? It is 14. And next one will be, if you just draw a line from here, how many? 1, 2, 3, 4, 5, 6. It is 12. And plus 3, it is 6. So that is 18. So what is the rule here then? Actually, we are starting with 6 dots, right? And each time we are adding 4 dots to draw the next figure. So here we have 6, 10, 14, 18. Next one will be 22. Next one will be 26 and dot, dot. Now find a formula that connects n and d. Find a formula that connects n and d. In example, a formula for the nth term of the sequence in A. Alakbar, what do you think? Can you just tell me what is the formula here?
I don't know. Idea.
Selin, how about you, Selin?
Do you hear me?
Yes, Selin, do you have any idea? Here in the question B, it says find a formula, right? That connects n and d. And what is n? It is the number of the figure, right? It's the first, second, third. If we just continue this pattern, in nth pattern, how many dots will be? Can we actually express this in terms of n? Okay, I think you see here the first number is 6, here it is 10, and here it is 14, right? So what we are adding here, each time we are adding 4, right? So that is, here we have 6 plus, to the first one, I'm adding 0 fourths. So here we should write here n minus 1 times 4, right? And here, what is n? N is a natural number, 1, 2, 3, 4. Now, if I simplify this, here we have 4 plus 4 times n, it is 4n. Negative 1 times 4, negative 4. So this will be equal to 2 plus 4n. So dot, 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 our answer is this d will be equal to 2 plus 4n. As you see here, if n equals 1, this one, n equals 1, how many dots here we have? 4 times 1, 4, 4 plus 2, it is 6. So here we have 6 dots. How about if n equals 2? If n equals 2, it is 8, 8 plus 10. Here we have 10 dots. If n equals 3 here, 4 times 3 is 12. 12 plus 2, it is 14. If n equals 5, it is 4. 16 plus 2, it is 18. Okay? Because each time it's actually here, it's increasing by 4, right? It's increasing by 4. That's why here we will have 4. But in the first one, we're not adding any 4. That's why I wrote here n minus 1. So the general term of this number sequence is 2 plus 4 times n. And the next question, using the formula in B. What is our formula? Our formula is this, 2 plus 4 times n. Find the number of dots there will be in figure 30. So that means that figure 30, right, that is in figure 30, how many dots will we have? That means that n is equal to 30. So in figure 30, we will have d equals 2 times 4 times 30, which is equal to 120. There will be 122 dots in figure 30. That is actually the point of finding the general term. As you see here, if we try to draw all the figures here, it will take a lot of time. So now, without doing this, now we know the pattern, right? And we just get the general term for this number sequence, and using this general term, now actually we can just actually tell any figure actually how many dots does it contain. How about the second part? In the second part, it says that find a figure that has 42 dots. What does it mean? It means that what figure, actually let's say figure n, that has 30 dots. Here d is equal, not 30, 42 dots. Okay, we know how actually d and n are connected to each other. That is d equals 2 plus 4n, right? D equals 2 plus 4 times m. Here d is given 42, and from here we need to find n. 2 plus 4 times n, and from here what is n? N is equal to 10, right? Because here take to the left hand side, 42 minus it is 40. 40 equals 4 times n. 4 times what number equals 40? N equals 10. That means that in figure 10, there will be 42 dots. Ibrahim, are you there?
Yes, mister.
So why you don't show us your face today?
Because I was take a shower and my head is very bad now.
Okay, good. Guys, continue. If you have any questions, anytime you can raise your
I'm
hand,
here,
or you
but
can just stop, okay? Ask me. And try to solve these questions. You will see that Al-Akbar, Ibrahim, and Salim, you're just grade 7, maybe you're like 12, 13, or 14 years old. As you solve more and more problems, as you understand more and more, and you'll actually love learning more and more, because this is a very important rule in life. If you understand something, you will like it, you will love it, right? If you don't understand something, actually you will be its enemy. So you don't understand, for example, let's say one question you don't understand, try to solve a bit easier one, okay? And you don't understand this, you can just take a picture. Now we are living in technology era, right? Time. Take a picture and send it to me. It will reach me in maybe a couple of seconds. I'll have a look and I'll just send you some hints or some suggestion, okay? So this should be your learning habits. At the time you will learn a lot. So you don't have to wait for the next class if you don't understand any question. Okay, guys, let's continue. Another example about general term in a number sequence. Consider the pattern. 2, 6, 12, 20, 110. 2, we can write it as 1 times 2, 6, 2 times 3, 12, 3 times 4, 20, 4 times 5, and 110, k times k plus 1. Write down the 8th line in the pattern. So what will be the 8th pattern? So 8th line in the pattern, as you see here, that is the first line, 1 times 2, second line, 2 times 3, third line, it is 3 times 4. So 8th line will be 8 times 9, which is equal to 72. And in question B, find the value of k. Here, what line is it? Actually, that means k's line. We need to find the value of k. How do you find this? Since k times k plus 1 is equal to 110, the question is, can we write this 110 as a product of two consecutive natural numbers or positive integers? What are those numbers? I think it's a small number. As you see here, I can just write it as 10 times 11. 10 times 11 is 110, or that's equal to 10 times 10 plus 1. So from here, dot, 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 what is k? K is equal to 10. So in kth line, here we have 110. Another example, that's the last question for today. And I think you'll continue next class, because after that also I have class. Draw the next two patterns and complete the table. Okay, each time, right, to draw the next, we are adding two more sticks here, and here we will have another figure here. Okay, how can I draw this? Maybe here we have 1, 2, 3, 4. In the first one, we have one triangle. In the second one, two triangles. In the third one, 3. Fourth one, 4. And the next one, we will have 5 triangles, right? Here, something like this. 1. And here we have 2. And here we have 3. And here we have 4. And here we have 5, right? And another one, I can continue. I can draw another one. Here we have 6 triangles. Pattern number, the first pattern, second pattern, third pattern, that is the first one. This is the second one. And this is the third one. And this is the fourth one, fifth one. And number of lines. Here we have 1, 2, 3 lines. In the second one, 1, 2, 3, 4, 5 lines, right? Third one, 1, 2, 3, 4, 5, 6, 7 lines. Fourth one, 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. And it continues. As you see here, number of lines, I can write it as 2 times 1 plus 1, 2 times 2 plus 1, 2 times 3 plus 1, 2 times 4 plus 1, right? How many lines and triangles are there in the 10th pattern? So as you see here, this one is pattern number, right? First pattern, second pattern, third pattern, fourth pattern. Now from here, I can have the general formula here. Now, what is the number of lines? Number of lines, let's say it is capital M. That's equal to 2 times n plus 1, right? And how about the pattern? In the first pattern, we have 1. In the second pattern, 2 triangles. Third one, 3. Here we have no problem. So how many lines and triangles are there in the 10th pattern? In the 10th pattern, if you just substitute here, that n will be equal to 2 times 10 plus 1. So that's equal to 21. In 10th pattern, there will be 21 lines. And how many triangles we will have? We will have 10, because the first pattern, we have 1 triangle, second pattern, 2. And how about in 121st pattern? So in 121st pattern, there will be 2 times 121 plus 1, which is equal to 242 plus 1, 243. And how about the number of triangles? Number of triangles is the same as the pattern number. So that's equal to 121. C, write down the formula connecting the number of lines and the number of triangles in a pattern. So since number of triangles is equal to pattern number, so at the time it will be equal to 2 times n plus 1. Okay. So n is, what is it? The pattern number. And this one is the number of triangles. Okay, Alakbar, Ibrahim, Selin, thank you very much for today. I will stop here. And also I will send you these questions. You try to solve these questions. You will see that they are not so difficult, but just knowing math is not enough. And also you need to learn math concepts here, math terminologies here, vocabulary. Also, you will improve your English. Okay, guys, do you have any question?
Yeah.
No.
Yes, please, if you have any question.
What's our homework?
Now I will send you homework. This from chapter 6, okay?
Okay.
Okay, you will receive it in the group and try to do these questions.
Okay.
Okay. I'm waiting for test 1. You have to submit test 1. After that, I will send you test 2.
Mr. Kazim, do I need to submit in the Google Classroom or either in the WhatsApp?
Selene, it's up to you how you submit. You can just submit me through WhatsApp. That is much faster. Also, Google Classroom, whichever you like, is fine for me. Okay?
Okay.
Okay. Guys, thank you very much then. See you on when? Thursday, right?
Yeah.
Okay. All right.
Yeah.
Goodbye,
Bye-bye.
Mr. Abu Chazan.
Bye-bye. Thank you
Bye.
very much, Ibrahim. Alakbar. Bye-bye.
Thank you very much.